this session. Do you have any question or anything from the last session?
No.
Okay, let's keep going. Calculus 3. Function of several variables. Okay. Aim of this week, or this session better, understand and visualize functions of more than one variable. Such as f of x and y equal to sine y e power x over. You know, before that, you have the function like x equal 2 plus 3y, or y is equal to x squared plus 2, you know, one variable. But now, in this session, we want to see one function more than one variable. For example, x or y equal half of the mv square. M and v, both of them are variables. Okay, let's go and let's see how it's looking. In this situation, what is the domain? It means that if this is the domain, is valid input and this is the codomain. Today, the domain would be, today we are interested in domain R square or R cube. For example, R square like E, M, and V, mass and velocity, is equal half of the mv2. It means that the function of more than two, more than, better write one variable, more than one variable. Okay. For example, f of x and y equal to square root of the x2 plus y2 minus 1. Now look at this one. If I put 3 and 4, your answer would be x3 would be 3 square plus 4 square minus 1 it would be a square root of the 24. But if I write here f half and 0, look at here. You have a half a square plus 0 square minus 1. It would be equal minus 3 over 4. And it is the problem because you have a negative under the square root. It means that the symbol square root of the x means non-negative, yes. We have a problem here. It means we should change the domain. It means half is not in the domain. It means that 1 over 2 and 0 is not in the domain of f. It means that the natural domain of a function is the set of all inputs for which the formula makes sense. You cannot use any input, because now if I use the half of and 0, sure your output is negative, and you know that the under the square root of the square root never be negative. If I show this one in the plot, I mean if I show you f of x and y, x2 plus y2 minus 1, it means that the x2 plus y2 minus 1 should be more than or equal 0. Yes, this is your restriction. It means that the x2 plus y2 more than equal 1. Can you guess x2 plus y2? But how could be this the shape of the x2 plus y2? Can you guess? Okay, x2 plus y2 is the circle. If I write here x2 plus y2 equal 1 is a circle that your radius or is 1. Okay. Okay. Now x, you want x2 and is 1 here, 1 here, minus 1 here, minus 1 here. You want the more than 1. It means that this line, because you have an equal and more than 1. Your domain is all this part. It means that the domain x and y belong to the R square, and x plus y2 more than equal 1. It means that all points on and outside the unit circle. Another example. G of x and y equal ln x over x plus y. Okay. If I want to show you domain after this one, can you tell me what is the restriction here? What is the restriction? You have a ln, you have a square root. What do you guess?
X plus y greater than 0 and x can equal to 0.
Yes. Now we add this one together. Okay, just I should tick you are in the class. Okay. Okay. Now, if I want to show you this one, again, x and y, okay? Now, it means that the ln of x, it means x should be more than 0. And for this one, x plus y more than 0 as well, not equal 0, because it's in the denominator. If in denominator get 0, you don't have any answer, okay? Now let's for the domain. X equals 0 would be this line. I put dash line because x more than 0. Yes, I don't want x equals 0. And would be all this part. X plus y or x equal y would be this one. But again, this one x plus y equals 0. And this one is x equals 0 line. But again, I put a dash line because it's more than 0. If I want to show you this line, it would be this part. What is the union between these two parts? Is exactly this yellow part. It is the domain. It means that the domain, the x and y belong to the R square, x more than 0, and x plus y more than 0. Okay. Now you think, how do we graph of a function of two variables? What do you think? What the graph look like? Such a this graph. Can you graph in the 2-dimension, or you should use the 3-dimension? What do you think?
2-dimension.
3-dimension, exactly. X or x, y, and z. For example, x and y, z equal f of X and Y. Yes, you have a 1, 2, 3 dimension. Example such as this point. Okay. The student joined the class. I just write his name. Okay. Now, for example, another example. If I write f of x and y equal x2 plus y2. Let's see how it's looking. Now I use some software. Here is online software. Let's see how it's looking. X where's the problem? Okay, for example, plot x squared plus y squared. Come on. My tablet is asleep. X. Let me share with my laptop. Okay. Now I should go to the whiteboard and then back there again. Okay. Okay. Mm, okay, now it's working, hopefully. Okay, you can see I use the x square plus y square. And the plots show you like this graph of the x square in the y square. And you know, you have a x, y, and z because you have a more than two variables. And for example, another example, because you cannot plot this one by hand, you should use software. For example, plot x, y. Look at your graph. You can see this one is another example, or the first one that I told you today, sine y, better put in the bracket, sine y, e over x over 5. Okay, you can see for each of them you can see the graph, and also you can see the contour plot. Contour plot, it means you are looking the graph from the top, you know. For example, you go to the airplane and look at the floor from the sky, you know. You see the mountain, but it's, for example, round, or you see the lake, but it's round, but you know, you don't see the volumes, you just see some contours. Or for example, the previous one, you can see again the contour. It looks like you are looking this one from the top, or for this one. Again, you can see the contour plot here. Okay, now back to the, okay. Back here. Now we want to write another topic, another way of visualizing functions. It means contour plot. For example, f of x and y equal xy. The easiest one that I show you. Okay, if I plot this one here, because I cannot show you this one in my tablet, just I plot it for you guys. It looks like this. Then I will explain for you. Just let me to plot them. Okay. do the contours look like? I write x, y equals c. If I put c equals 0, it means x, y equals 0. Means this line. X or y equals 0. If I put c equal 1, it means x, y equal 1. Which line would be? This line, x, y equal 1, or is minus 1 and minus 1. It's x, y equal 1. If c equal 2, means x, y equal 2. It means this line, equal to x, y equal to. If I choose minus, it means x, y minus 1. It means one of them should be positive, one of them is negative. X negative or y negative doesn't matter. Here x, y minus 1, x, y minus 1. It shows you the contour, contour plot. Each contour is a curve. And known as a level curve. For example, this contour, I write here 300, 200, 500. What's that numbers in that shape? Is level of curve, level of, let me write here, level curve of f of x and y is 300. It means, for example, you have a mountain. If look at from the top, you see just this line, but this line, the height of this line is 300. And I can write here each level curve is defined by f of x and y equal c. As I show you before, that you can see the level of the curve. Just let me show you again here. Today my computer look like doesn't work very well. I don't know why. No. Look at here. Each contour show the different colors to show you different height. And one thing you can see using the contour of for the various output. For example, You can use this one in the medicine for to do some MRI or something like that. In that MRI with different color, you can see everything. For example, how it can look like if I write here, for example, brain. MRI scan. And I show you some images. Look at here, for example, exactly. In this image, you can see, show you different color between this different area, and each color means different for a density. For example, light, higher density, dark, lower density. You know, in the contour, the height of the contour and the shape of the contour is very important. Okay, if we back here, let's be back to my tablet. Okay, come on. Okay, now what about function of three variables? Like MRI scan, you can cut the input and put in the different level. Cut the input into slices, treat, check, treat, or treat each slices. A set of 2D input. You know that the brain MRI the brain is 3D, yes, but for the reading better, we divided this one to the such a dose, for example, to divide it to the copy this one back here. Okay. We divided a slider to the sum part, and we can make it in the two dimension, and we can analyze this one better than the 3D. It means the function, this function f of x, y, and z is equal density of point x, y, and z. For example, light line is higher density and dark point is show lower density. The other way that about the function of the three variables, we can say one variables most of the time are time. 2 time series use t equal time as a third input, coordinate visualization is a video. For making video, you have this 2 input, for example, and the third input should be time, and you have a function of the three variable. And also contours. We'll talk about that one. Each contour is a surface called a level surface. F of x, y, and z equals c. And you have the other show for the 3D. You can show the slide, you can show with the contour, or the third variable would be the time. For example, f of x, y, and z equal to x2 plus y2 plus z2. Okay. If I want to show you this one, let me check again. Hope this one working, because it's better to disconnect it and back again. Don't know what doesn't follow my laptop. Okay, back again here. Plus that. Let's go. Okay. X square, y square plus z square. Or for example, I put equal 1. Look at here. Give you some sphere that this sphere is the radius is 1. As you can see here, the level of the surface here is 1. If I put 2 here, give you the sphere that the level of the surface is square root of the 2. And this is show you the level of the surface. You have a 3 input and show you the contour, show you the level of the surface. And now if I want to show you, for example, let me show you something here, then I will explain for you in my laptop. Okay, if I write here, z equal to, for example, sine square root of x power 2 plus y power 2 divided by square root of the x power 2 plus y power 2. If I write here plot I think my internet today is not very well. Make it easier this one. Take less time. Okay. Now, less time. Sine square root of the x square plus y square. It look like you apply sine x and then rotate around the z-axis. You can see here, it looks like you plot the sine x and then you rotate this one around the z-axis, and the contour from the top show you this one. If I back to my notebook and show you here. Okay, I can write here surface of revolution. Graph of z equal f of x in for example xz plane for x more than equal 0. Now we rotate about the z-axis. You have, for example, one graph. Let me you have a x, y, z. You have, for example, this graph, then you rotate, and would be something like this. You rotate around the z-axis. Now this shape that you saw there, it was the f of x equal sine square root of the x2 plus y2. Yes, it means they rotate the graph of sine x2 plus y2 about the z-axis. If I show you in the 3D, in the 2D, 2-dimension, it is look like this. Then you rotate it. It look like this, and you rotate it, and you saw it look like the one hole on it from the top. This is the revolution of the surface. Okay. This part is better. You use some software. You can use any software. You look the Wolfram, or you can use the MATLAB, any software that you are happy with that. Show you how the graph looks like, because you cannot plot the 3D graph with hand very well, but the computer give you a hand plot those graphs. The other part for the today is the partial derivatives. Partial derivative. Okay. For example, you had before in 2D, if you have this graph, for example, y equal f of x, a slope of the discord is a slope of this chord is equal delta y over delta x. Yes, you have this one because you have a 2 point here. You make a triangle, you find the slope. For the 2-dimension, and a slope of the tangent at x0 and f of x0 is limit delta x goes to the 0, delta y over delta x is equal, and limit delta x goes to the 0, f of x0 plus delta x minus f of x0 over delta x. It's approximately equal f prime x0. Yes, you have this one before for the find the derivative. Now you're about to this topic, partial derivative for more than one variable. For example, f of x and y equal 1 minus x2 plus y2. More than one variable. That one just for the one variable, now is for more than one variable. What should we do? We write, I start from the technique part, and then I give you more way to solve this one very easy. Okay, don't worry, it's very easy. It looks like the delta z over delta x is limit delta x goes to the 0. Now f of x0 plus delta x and y0, because now you have a 2 variable here, minus f of x0 y0 over delta x. It means this one would be equal to a slope of the graph of z equal fx and y in the direction of the x-axis are also equal to derivative of fx and y0 with respect to x, where y equal y0, and you can write this one as a f of a respect to the x, x0, y0. You can see, write this one as a usual form, and I solve this one in the usual form, then I give you more technique, okay? Now again, let me copy this one. Paste here. Okay. I can write here, this one is equal to limit delta x equals 0. Now, 1 minus x0 plus delta x power 2 minus y0 power 2 minus 1 minus x0 plus y0, both of them square, over delta x. I put x0 plus delta x as a x, y0 as a y for the first term, and x0 as a x and y0 as a y for the second term. Like, would be equal to limit delta x goes to the 0. 1 minus x squared 0 minus delta x. You open this one to x0 delta x minus y0 x2, and it's 1 minus 1 plus x0 2 minus y0 2 over delta x. This one by this one cancel, this one by this one cancel, and this one by this one cancel. At the end, you have a limit delta x to the 0 is minus delta x squared minus 2x0 delta x over delta x. You can factorize 1 delta x and delta x to the 0 and minus delta x to x0, and this one goes to the 0, and at the end you have a minus 2x0. It is the derivative of the f to respect to the x for the x for 0. Okay. Now I can do this one as this way as well. No, I write again here f of x and y equal to 1 minus x2 plus y2. I can write f of x and y is equal to, what's that mean? That means you can derive just respect to the x. Now is y is look like the constant number, okay? Derivative's constant number is 0. Am I right? Okay. It's 0 minus 2x plus 0, because y is again constant number. Is minus 2x. You can do such a this big way or use this way, okay? It means we can compute this by just keeping y constant and differentiate with respect to x as usual. For example, again this one, if I write f, y, x and y for this one, what do you think? What do you think?
To y.
2y minus 2y, exactly. Round over round y minus x2 plus y2. Now, exactly, it's 2y. Sorry, it's plus. It would be equal to 0 minus 0 plus 2y. Okay, another example. G of x and y is equal to x2 plus xy minus cosine y. Okay, can I give me the answer about g of x, x and y, and also g of y, x and y?
So gx is 2x and gy is sine y.
Just be careful, you have an x, y as well. For the first, for g of x, keep y constant, but you have an x before the y as well.
So it's 2x plus 1.
Exactly. And what about the jy, xy?
1 plus sine y.
X plus sine y. Okay, let's do it. Round over round of the x, x2 plus xy minus cosine y. Okay, here keep y constant. It looks like round the x, x2 plus round xy minus round over round the x cosine. If we keep x constant, this one would be 2x plus y minus 0. Because y is constant, it looks like round after round the x. If y is constant, it looks like the cx. C is y is equal c. And for the The other one is would be equal to round over round y x2 plus y2 minus cosine y. Now this one, keep x constant. It means that the would be equal to round y x2 plus round y y2 minus round y cosine y. It would be equal to, this is the 0, is constant, plus, sorry, is here xy, plus x plus sine y. It is very easy, just need more concentration, yes? Now, for higher partial derivative. You know that the f of x respect of the x is round of the xf, but f of x is look like round of the x. F of x is look like the second derivative of the x. That I can show you this one as f of xx, and fx y I can show you round y. F of x is equal to round the y, round the x. F, it would be f of xy. Okay, what those means? We can do derivative with respect by x, xy, or yy. Let's see how it's looking. I will show you with example. F of x and y is equal to x2 plus y plus sine x plus 2y is your function. Now I write here fx. Respect to the x, I can write here round the x. x2, just give me, put this time, multiplication is better, plus sine x plus 2y. This would be equal. Now y is constant. 2xy plus cosine x plus 2y round the x inside the bracket. As you know, the y is constant, should be this one 0, and the derivative of this one would be 1. At the end, you have a 2xy plus cosine x plus 2. Now I want to write here fxy. It means that the round y f of x. We calculate f of x, yes? This is f of x. Now I write here round y. 2xy plus cosine 2y. Sorry, cosine x plus 2y. Now, derivative here is x is constant, yes? It would be equal to x minus sine x plus 2y round y x plus 2y, and remain here, this one is 0, from here remain 2, is equal to 2x minus 2 sine x plus 2y. Now, if I want to calculate the fxx, again, you have f of x. Now, round of the x, f of x is equal round of the x. What is the f of x? Is 2x plus cosine x plus 2y would be equal to derivative of the 2x would be 2x would be 2y minus sine x plus 2y round of the x plus 2y. Again, this one 0, this one 1 would be equal to 2y minus sine x plus 2y. And if I write here, let me copy this one. And paste here. Okay. Now give me again, what is the fy? What is fyy? And what is fyx? Do you find the answer?
I'm not sure.
Let's do together. Fy is equal to round the y x to y plus sine x plus 2y. Derivative to the y, x to its constant. It looks like the, for example, 5 squared y. Okay, derivative would be x2 plus cosine x plus 2y round the y x plus 2y. Again, y is the constant 0 and the remainder x is constant is 0 and the number before the y is 2 is equal to x2 plus 2 cosine x plus 2y. For f by y is round the y. Fy, you find the fy is equal round the y, and fy is x2 plus 2 cosine x plus 2y. it would be equal to, this one doesn't have any y is constant number and derivative is the constant is 0, and minus 2 sine x plus 2y, and the y x plus 2y, again x is 0 to come out, minus 4 sine x plus 2y. And fyx, you have the round of the round y, f of x here, and for here you know that the round of the x, and fyx, sorry, round yx. Round of on the x, fy would be equal round of the x, and would be x2 plus 2 cosine x plus 2y. It would equal 2x minus 2 sine x plus 2y round over round of the x plus 2y. And at the end, you have a 2x minus 2 sine x plus 2y. As look at here, fyx and fxy now are similar. It happens sometimes, but not all the time. And you have here one theory. The theory name is the Clairaut theory. Clairaut theory. What's that mean? If for the function f of x and y, both fxy and fyx are continuous on same domain, then on that domain f of x, y, and y is equal f of y x and y. It means not happen every time, but it's happen. It means that is the Clairaut theory. Okay, it means that if you have a f of x and y, you can derivative by x, you can derivative by y. By x you can show f of x, by y you can show f of y. Again, this one you can derivative by x and y. This one derivative by x and y. This one would be fxx. This one would be fxy. This one would be 5yx, and this one would be fyy. And sometimes these two are equal. And when they are equal, you have a Clairaut theory. Okay. And now, for example, another example. GSTU, 3 variable, equal to ST2 plus TU. Can you give me what was the GS? Is round of the S, ST2 plus TU. You know, when you are doing the derivative from the respect to the one variable, you keep that one as a variable and the other variables are constants. It's very important. Now focus on it and give me the answer.
T squared plus T.
T squared plus T. Do you have any S in the second term? First term,
No.
okay. When you don't have any S, it means T and U, both of them look like the constant number.
Oh, okay.
Now, what is the result?
T squared.
T squared, exactly. You know, this one would be equal T squared plus 0 is equal T squared. Okay. What about GST? GST means that the round of the T of the GS and is round of the T, and GS is T2, yes, and the answer is 2T. Now give me the answer about GU and GUT.
GU is GU equal to T, and
Okay,
GUT is 1.
exactly, perfect. Is equal to run over the run here ST2 plus TU. Again, U variable, the other variables look like the constant number. Is equal Z plus T is equal T is and round of the T. GU is T, sorry, one more step, round of the T, and this one would be T and would be equal 1. Okay. Okay. I think it's enough for today. I show you the function of the several of the variables and check how is look like going, and you have a contour plot. For the contour plot is the best way, use the software, and each level the contour is look like the surface level, which different level is look like you are looking from the high. And also the other part that you have here, very important, is not big deal in partial derivative. When you are doing the derivation, respect, for example, to the x, get x as a variable, and the other variables look like the constant number. And then do it the derivative. It doesn't matter how many variables you have, 10 variables, 15, doesn't matter. It look like one variable, okay? And for this one, okay, I think I finished the topic for the last week, week 2. And this Thursday, again, we have a class at 10 a.m. as same as before, 10 to 12. And again, sorry, I laying down because I had a surgery last week. I was in hospital and I canceled the class because of that. And hope everything will be okay. And I see you on Thursday.
Okay, thank you.
Thank you. Have a good afternoon. See you on Thursday. Bye-bye, guys.
Bye.